Hello everyone. If you're here already, please leave a hi or some message so that we know that you're here. And I will start the session right at 11 o'clock in another 3 minutes. Hello, testing if it's working now. Hello. So I believe it's working now. And if you leave a hi, if you're here, it'll help me know who all are here so that we can start. Hi, can you hear me now? I believe it should be fixed and running. Please leave a comment here if you're here online so that I can know who all are here. We'll start the session now. We are 5 minutes late. I'm sorry about it. So, am I visible now? So, we were discussing about metric spaces so far. For those who were not here in the previous discussion, will quickly recall what we were talking about earlier, and then we'll go ahead to continue with the counter examples we were doing along with some extra challenges, and during those challenges I'll be presenting more examples and counter examples which you can make note of. I'll be talking about how we can generate more examples, some pattern on how we can generate more examples. So uh, can you leave a hi or message in the chat for so that I can know who all are here? So let's start the discussion now. I started by quoting Neil deGrasse Tyson about how science literacy is not about what you know, not about how much you by heart, but about how you train yourself to think science, how you train yourself to ask questions. And I told you this will be the main focus of our teaching, our channel, and whatever content we are delivering through this channel. So you might have already seen, instead of leaving a definition by giving you a definition and discussing it for 5 minutes, we are talking about it for 2 or 3 hours now, because it's absolutely important that we understand the definition really well. And in fact, in when it comes to entrances, you're not tested on how much do you know, how many definitions you have by heart, but rather you're tested on how well have you understood the definition. So we will see all that today once we start doing the challenges and CSIR-NET questions. So we discussed about this definition, and we noticed that to define a metric space, we need M to be a non-empty set, and we defined a function called rho, which is called a metric on M, on this particular set M, if it satisfies these conditions. And usually when we talk about definition of metric spaces, when someone asks you the definition of metric spaces, you'll be quickly caught the four conditions which are given there, which are numbered. But last week we noticed that those four conditions are not the only conditions required to define metric space. In fact, going ahead, we'll see that we notice that there are six conditions in real, and first condition is on the domain. That domain should be M cross N. Range should be contained in 0, infinity closed interval, and then those four conditions. Now, then we went ahead to talk about where this definition came from. Instead of just by hearting the definition, we started looking at where did this definition come from. There was this, I forgot to mention something, how to start with that exploration. How we can start with it is, look at the name of this particular object we are trying to define in mathematics. It's called metric spaces. The English word metric means distance or measure of something. And we should get a hint from there itself. Metric, we are going to measure something, and metric is something we use for distances. So this has something to do with distance. And then when we were trying to understand the definition, we took triangle inequality. We took, when we are trying to understand triangle inequality, we took a hint from the word given, the triangle. So it has something to do with triangle. And then we looked at x comma y being flipped. So it has something to do with symmetry. So sometimes mathematics is so real world. You can just look at the name of the particular definition that we are working on, and we can take hints on how to understand its origin. Where could this be? What could be the real world concept that we have tried to formulate into mathematics here, mathematical terms here. Now, I also emphasized on the word called abstraction, and I said abstraction is a heartbeat of mathematics. Now, abstraction is not abstraction is not an idea that should be learned only by the top mathematicians out there like Cauchy, Gauss, Euler. This is a word that every mathematical student should be taught of. And during this course of classes, we'll also focus on developing those skills. At the same time, we'll be fast paced so that it will help you for your entrances and the exams that you're going to write. Now, we noticed two examples. One is real numbers, real line with absolute value metric or Euclidean metric, or simply we would call it usual metric. Then we talked about something called discrete metric, which was super powerful. We observed a lot of interesting things about it. And we also observed three properties here. From the two examples we did, we observed three properties. One is, one set may have different metrics. Same metric may work on different sets. We can find a metric on any given non-empty set. And there were some brilliant thinking which was done during this class, during the last session, that which popped up as questions in the chat. So in this particular class, we'll be continuing our discussion on counterexamples. Then we go ahead to do some challenges and some extra challenges. So it'll be good if you have a pen and paper ready with you, so that you can quickly make a note of whatever question is posted. Try to note down your observations, try to develop it further. So grab a pen and paper and be ready. I think we did 4 counterexamples. We'll have 1 or 2 more counterexamples, and then we'll go ahead to challenges, some extra challenges, and CSIR-NET questions. Now, before I start counterexamples, let me remind you of some questions which popped up in last class. Few of them, few interesting questions that Nikita had a question whether if there is a metric which works on any given set, and Bijal pointed out that there can be one. In fact, the discrete metric which we were talking about earlier, that would work on any given set which is non-empty. And then Nikita had another doubt, which was really good thinking. Will Euclidean metric, which was defined on R is supposed to be one of the sets which gives us a lot of basic ideas, right? So she was wondering if it can be applied on any given set, Euclidean metric. Euclidean metric is nothing but our absolute value metric on R. And we noticed that Euclidean metric cannot be applied on any given set, but it can be extended to subsets of R or restricted to subsets of R, or to R square, R cube, R to the power n, the Cartesian products of R. So we will see that in some time, in possibly when we come to extra materials, extra reading materials and extra puzzles. So hopefully that will be done tomorrow or day after tomorrow. Now, Bijal had a question with which we closed our discussion last week, which was, forgive me, there is a small trouble. Bijal had a question on for every metric, should 0 be in the range? Because we don't explicitly say in the definition, nowhere in the definition we say that 0 should be there in the range of every metric. And turns out in one of the examples one of the counter examples we noticed, we noticed that 0 must be an element of the range of any given metric. We'll quickly go through those counter examples and then we'll continue with the other content. First counter examples we noticed is, consider any set M. Can this function given by rho from M to closed interval 0 comma infinity be a metric? Now we notice that this cannot be a metric because domain should be M cross M and not M. So clearly this cannot be a metric. Now we went on to the next counter examples. The counter example which asked, consider any set M with 2 or more elements, and we were wondering whether the function rho M from M cross M, domain is fixed, domain is correct, and codomain is singleton 0, which is again perfect. It's a subset of range. Range is a subset of closed interval 0 comma infinity. Can this be a metric? And turns out it cannot be a metric because for the second condition here, for any non-equal, if x and y are not equal, we need rho of x comma y greater than 0, which will not be possible in this particular case. Hence, rho of x comma, this particular function rho from M cross M to 0, singleton 0, cannot be a metric. Now, I think we stopped with this particular counter example yesterday. It said, consider any non-empty set M, a function given by rho from M cross M to open interval 0 comma infinity, and we claim that this cannot be a metric because of the first condition, and that had to do with Bijal's first question. That had to do with Bijal's his first question. Rho 0 is not a member of this codomain, that is, so but in the first condition here it says rho of x comma x is equal to 0. Rho of x comma x should be 0. That means Indirectly, though the definition doesn't explicitly demand 0 to be in the range of the particular metric, indirectly with the first condition here, the first numbered condition here, we are assuring that 0 should be a member of this particular matrix range, and hence this cannot be a metric. And this is where we discussed our discussion, this is where we stopped our discussion yesterday. Now let me point out something really interesting. These ideas that 0 should be a member of the range were all brought by you during the discussion, and I really appreciate your thinking, because it takes a lot of thinking to come up with such questions, and I see real mathematical thinking in each one of you who asks a question. Even if you feel if your question is valid or not, please feel free to ask the question so that we can clarify it. Don't hesitate to ask your questions. And as when you ask the questions, either I will directly answer it, or Vivek is already in the chat and he'll be quick to respond to it if I do not respond to it soon. So please feel free to respond. And one more thing, today we'll be going into challenges, and challenges are I'm going to display a question. I'm going to wait for you to give your response. So whatever your thoughts are on the particular challenge, leave a comment. It'll help us understand it better. So feel free to open up your mind in the chat box, and be ready to answer questions. Be ready to type in your answers, send it across as soon as possible. Try to think through it. It takes a lot of practice to think through a certain concept, try to apply it. So don't worry if you cannot answer. So let's continue with the next counterexample. Consider any non-empty set M. Function rho from m cross m to 0 comma closed interval 0 comma infinity. Domain is alright, no issue. Defined as rho of x comma y is equal to x. I'm claiming that it cannot be a metric. I'm saying it's a counterexample. So why is this? Why can't this be a why can't this be a metric? And which numbered condition does it contradict here? Which, no, not just the numbered condition. Why is this not a metric? Give me at least one reason. I can think of 3 or 4 reasons at this moment. Why can't this be a metric on M? It Mahesh says it counters condition 1. Why? How? Others can leave your thoughts as well. It's not. It's okay if you. It's okay. Don't look at others' answers. You can leave your thoughts alongside. Yes, Pranidhi, 3 is not satisfied. That's also true. But why did you, Mahesh? Can you type why is 1 not satisfied? Bijal, you have brought out a really good thinking, because I didn't expect anyone to notice that particular fact. So those who answered 1 and those who answered 3, leave your thoughts on why you think and how do you think. In what case will it count? In what case will it be not satisfied? And Bijal, your answer as well. That's really good thinking, because I didn't expect anyone to come up with that question. I'm sorry, I switched off the audio and I forgot. So Mahesh just pointed out that the first condition is not satisfied here because row of 1 comma 1, if m is equal to r, row of 1 comma 1 will be equal to 1, which is not equal to 0. I'm sorry, Bijal and Pranidhi, I hope you can hear me now. Yes, so that's a counterexample for that's a way of saying this cannot be a metric. Those who pointed out 3, why? Can you point out why 3 is not satisfied? Again, 2 is also not satisfied. Condition 2 is also not satisfied because, as Mahesh pointed out, p of 0 comma any number will be equal to 0. Hence, trivially, condition 2 is also not satisfied. How is condition 3 not satisfied? If x is not equal to y, what happens? If x is not equal to y, then row of x comma y will be equal to x and row of y comma x will be equal to y. They are not equal, hence condition 3 is also not satisfied. So during the exam, you need not run in and check all the conditions. If one is not satisfied, stop your discussion there. But when you are studying, make sure that you check each and every one of the conditions. Now, Bijal pointed out something really interesting. It depends on M, the set you consider. Now, how is this? How will you explain it? Bijal, can you give me your thoughts on it? What will be M? Can any set be M? Can R be M be equal to R? It cannot be, mainly because M, if suppose minus 3 belongs to M, then row minus 3 belongs to M, then minus 3 comma say 3, row of minus 3 comma 3 will be equal to minus 3, which is not possible because our codomain here is 0 comma infinity, closed interval. Hence, we can be sure that M should be a subset of closed interval 0 comma infinity. And any other observations about M that you can make here? What if M is a singleton set? Yes, in this particular case, codomain decides M. In this particular question, codomain decides M. What if M is a singleton set? What can you say about it? Would this work as a metric for any set M? What about Praveen says no. So what about singleton 0? Singleton 0, M is equal to singleton 0. Yes, Pranidhi, that's a good thought. Hi, is it back live again? I'm sorry, there was a bit of trouble. So, as pointed out, if it's singleton 0, if it is singleton 0, what happens is I believe it's back streaming now. So yeah, let me conclude the discussion on this question. I'm sorry about the confusion. So here we first notice that this particular metric won't work for any set than a particular set, which we found out later, because it fails all three conditions. All these three conditions, and then we found out that depending on the codomain, our domain is also restricted. We can have only a particular set. This can be considered as a metric for only a particular set M, and that M should be a subset of closed interval 0 comma infinity. And we found that even in those sets, only for singleton 0, this will work as a metric. For any other set, any other subset of closed interval 0 comma infinity, this will not work as a metric. So I hope it is visible now, and I will continue to the next counterexample. We'll get on to the challenges. So this challenges section will be in this challenges section, we'll be looking at some symbol puzzles, and that will help us, one, get better insights about definition, two, learn how to apply the definition we just learned in a particular question. So can you just confirm if the uh, live is back up and if it's visible to you? So to begin with, the first challenge. Earlier I told you a metric for M is a function rho with domain M cross M and range contained in closed interval 0 comma infinity. So the first question goes this way. Can a function given by rho from M cross M to open interval minus 1 comma 1 given by rho of x comma y is equal to 0 if x is equal to y, 0.5 if x is not equal to y. This is similar to what we discussed as discrete metric. So can this be a metric on M? So leave your thoughts in the comments. I hope it's back in action now. Hi, is it back? So let me see. Let me repeat what I was just saying. So in this challenge section, I'll be showing you a question, and I'll be waiting for you to answer it. Leave your thoughts about it. These are all simple, not very complicated, and these will depend only on the definition that we discussed right now. Purpose of this challenges section is twofold. One, to help us understand the definition better. Two, to help us learn to apply the particular definition in context of a problem, trying to solve problems, trying to train ourselves to solve problems using that definition. So this is the first challenge. Take a moment to think about it. After a minute, leave your thoughts in the chat so that others will also have time to think about it. So let's give it a shot. It is depending on the first line in the definition, which says a metric for M is a function rho with domain M cross M and range contained in closed interval 0 comma infinity, such that, and the definition continues that way. The question is this: can a function given by rho, which is defined from M cross M to open intervals -1, 1, given by rho of x comma y is equal to 0 if x is equal to y, 0.5 if x is not equal to y, be a metric on M. Let M be, for easiness, let me restrict M to be R or any set. So Bijal and Praveen says it could be fourth condition. Praveen is doubtful about the fourth condition. We'll talk about it soon. Let's wait for others to leave their thoughts on it. Trinity says it cannot be. You can leave your thoughts now, and you can leave your thoughts in the comment now. Just leave a message. Trinity, why do you think it cannot be a metric? So Trinity felt that fourth condition will not be satisfied since rho of x comma y plus rho of y comma z will be equal to 1. 1 is not there in the range. So this cannot be a metric. That's your thought. Now, what happens if I include 1 in the range? Yes, that's also a good thought. But rho is not taking the value. Notice that in the fourth condition we said rho of x comma y should be less than or equal to, not equal to. Can be less than or equal to rho of something plus something. And that something plus something turns out it is 1. Then what happens? Rho of x comma y is less than or equal to 1, which is satisfied easily. Hence, we can easily say that this will work as a metric. And in fact, the trick I was trying to point out here is the codomain is -1, 1. And the definition specifically said range should be contained in 0, infinity. So here the range is set 0, 0.5, which is a subset of 0 closed interval 0, infinity. Hence, this works as a metric, and in fact, as Vijay just pointed out, it is just the same as discrete metric which we defined earlier. And it would have all properties exactly the same as discrete metric. And we pointed out something interesting here because everyone confused with the fourth condition, and as Vijay pointed out, Fourth condition, LHS is less than or equal to, it's not equal to, less than or equal to RHS. RHS is equal to 1, but that doesn't mean rho should take the value 1. So that's a good observation out there. Is it clear for everyone? Can we continue? If not, please leave a comment. I'll clarify it for you. Now, do you see the purpose of these challenges? These challenges are designed in such a way that it helps you think through the definition, think through finer details of the definition, helps you understand the definition well enough. So that's why, and also these are not very tough things. These are just simply discrete metric. We just change value from 1 to 0.5. We should be ready to ask questions of this sort when we are learning a definition. Take an example which is already given, pick something small, something trivial out there, and try to see what happens. That will help you, give you more insights about the definition than that you have never thought about. So yeah, since it's clear for everyone, let's continue to the next challenge. Are you ready? Challenge, I'm going to test the fact that consider any set M, rho from M to 0 closed interval 0 comma infinity cannot be a metric on M, as domain of the metric should be from M cross M. Question: can a function given by rho from R cross 0 comma 1, set 0 comma 1 to codomain is okay, be a metric on R? Take a minute to think, and I'll tell you when you can start posting your thoughts on the chat, as we'll give others a second to think through and come up with their conclusions. So when please try not to post your thoughts now. When I tell you, you can start posting your thoughts. So yeah, you can start posting your thoughts in the comments so that we can start the discussion. Can a function given by rho from R cross 0 comma 1, set 0 comma 1 to closed interval 0 comma infinity be a metric? I'm not giving you what this rho can be, what is this what is the definition or definition of this rho. I'm not telling you rho of x comma y is equal to something or something. I'm just asking you, from this, given this context, can this be a metric on R? It's an easy one. So what's your thoughts? Prenzi says if x comma y is equal to 0, when rho of x comma y is equal to 0, if x is equal to y, and no, we are not giving any such things. We are just saying rho is some function which with domain and codomain this. And can it be a metric on R? That's the question. Yes, Bijal, that's true. So again, I'm emphasizing on the fact that domain of the metric should be from M cross M. This cannot be a subset of M. It has to be M cross M. Here, turns out domain is R cross set 0 comma 1. Hence, clearly this cannot be a metric on R. Notice that this cannot be a metric on R. Now, when you see this, you should be automatically asking next question. So let's so it cannot be a metric on R. You should automatically ask, so the question I was asking is, can this be a metric on, it cannot be a metric on R, definitely. Can it be a metric on set 0 comma 1? Leave your thoughts in the chat. Cannot be a metric on R. Can it be a metric on set 0 comma 1? Yeah, I'll repeat the question. So we concluded that since domain should exactly be R cross R, this cannot be a metric on R. Can it be a metric on set 0 comma 1 was my question, Vijay. Yes, Pranidhi, that's true. What happens is, when it's set 0 comma 1, it is not exactly 0 comma 1 cross 0 comma 1, but this particular function can be restricted to 0 comma 1 comma 0 comma 1 0 comma 1 cross 0 comma 1, and hence this can be a possible candidate for metric on that set 0 comma 1. Anyway, that was a trivial question. Let's go to the next challenge. I hope it's clear for all of you. If not, please feel free to leave a comment. Either I'll address it or Vivek will continue. Vivek will answer your question in the chat. Third challenge. I told you that if A is a proper subset of M, a function given by rho 1 from A cross M infinity cannot be a metric on M. I'm going to define another. Hi, is it back alive? I'm sorry, I'm going to skip this particular challenge because we already approximately discussed this question. And I'm using words like restriction, which I didn't define before, and it may not be familiar for everyone, so I'm going to skip this particular challenge. So anyway, the answer, as you said, it's a yes, and so we pointed out in the previous example. The answer is yes, and this will work as a metric. So let's quickly go to the next one. Fourth challenge, consider any non-empty set M. We already stated this, that range has to contain 0. That's one observation we made in previous class. Let A be the question is this way. Let A be a subset of closed interval 0 comma infinity, and 0 belongs to A. That's for sure. Can any non-constant function rho from M cross M to A be a metric on M? Can any non-constant function be a metric on M? You can leave your thoughts quickly because we are running out of time. So you can leave your thoughts in the comments quickly. In fact, this is also a simple challenge. I have just played with the words. Pranati said no. Anyone else? Now, which fact am I playing with here? Earlier I pointed out that 0 should be there in the range. And here I am saying a set A which contains 0. That's assured. And I am asking if this can possibly be a metric. The fact I am playing with is, in the definition it said range should contain. And here A is not the range, A is the codomain again. A contains 0, that doesn't assure that the range contains 0. So any non-constant function cannot be a metric on M, as Pranidhi pointed out. So any non-constant function cannot be a metric on M. And this is the same concept which was pointed out in the counterexample. I'm reiterating it because I've just look at the way the question is worded. It's not, the question is worded in a slightly confusing way so that you'll, for a second, you'll think, oh, 0 belongs to 8, which is satisfied, which is a condition that we wanted to check earlier. So this should satisfy. But in fact, it was just tricking you into thinking that this is true. So leave a if it's clear for you, leave a comment. Otherwise, we'll proceed. If you have a doubt, leave a comment. Otherwise, we'll proceed to the next section. So this is what they do in almost all entrance examinations. Pick a very simple fact, twist it a bit so that you get confused, and unless you think through properly, you won't be able to get the answer. So this is one trick they you always use when they design question papers in most of the entrance examinations. So keep that in mind. Now, if there are no more questions, we'll go to the next challenge. So, for example, discrete metric here. Discrete metric works, but not all non-constant functions work. I'm sorry, I've typed it wrong. So yes, that's true. That's true. I've typed it wrong actually. No, its answer is no in the solution. I have typed it wrong here. Yes, that's true, Bijal. If if A is equal to singleton 0, that's the only thing which is assured here. Then again, as we pointed out earlier, it won't be a metric on M. Oh, let's go to the next challenge. We talked about the function rho of x comma y is equal to x, which cannot be a metric on M as it contradicts. Most of you pointed out that the third condition is what it fails. Rho of x comma y is equal to x, which is not equal to rho of y comma x. And most of you intuitively pointed out that condition as the wrong condition, but turns out we discussed further and we found that all three conditions go wrong. So let's see. The question goes this way: can a function rho from r cross r to 0 comma infinity closed interval given by rho of x comma y is equal to xy be a metric on any set with more than 2 elements? Here, earlier we discussed about rho of x comma y is equal to x. Here I am asking you about rho of x comma y is equal to xy. And let's take, for simplicity, let's take rho m is equal to r. Leave your thoughts quickly and we will move to the next challenge. Okay, I've made a small correction. So let's talk about R itself. Yes, Bijal, as you pointed out, row of minus 1 comma 1 will be equal to minus 1, which is a negative number. That means negative number should be there in the codomain or the range, which itself is fundamentally flawed in this construction. So this cannot be a metric. Now let me ask this question again with a slight modification. Suppose let me ask this question again with a slight modification. I'm going to change R to M, rho from M cross M to 0 comma infinity, given by rho of x comma y is equal to xy. Can it be a metric on any given set with more than two elements? Can there be any set on which such a function be a metric? Notice that I've just tweaked the previous question a tiny bit, generalized it a bit. Okay, I'll repeat the question, Bijal. Previously, we restricted ourselves to set R, the real numbers. Right now, I'm generalizing it a bit. Can the function rho from m cross m to closed interval 0 comma infinity given by rho of rho of x comma y is equal to xy be a metric on any set with more than two elements? Can you find a set M such that this works as a metric, which has that set M should have more than two elements at least? You can start working backwards. Is there any restrictions on M brought by the codomain here? Ask that question first, as Bijal asked earlier, and then try to see what could possibly go wrong. Yes, Mahesh. Mahesh said no. And yeah, most of you seem to agree that it cannot work. Why? Simple reason. The reason we have already told earlier. The reason is simple, right? We have already discussed it multiple times because rho of say 1 comma 0 will be equal to 0, which is contradicting the second condition. So earlier it was, I'm sorry about the buffering, there is a small problem here with the network setup. So earlier when I asked you the same thing, I presented it as a fact, right? That the same question were rho of x comma 0, when rho of x comma y is equal to x, I said it cannot be a metric because of this particular reason. But when I asked it to you as a question, it required a bit of thinking before you answer. So that's how you're tested in your entrance examinations. Questions will be asked in such a way that you will be made to think. And when you're preparing for entrance examinations, you should focus on developing that thinking habit rather than reading the question and answers on any. Can I continue for another 10 minutes? We are all past 12 o'clock. If it's okay with you, I will continue for another 10 minutes and finish one more this last challenge. Can I continue for another 10 more minutes? Is it all right? I hope it's back alive. So think about this question for a second. Uh, Consider set A is equal to open interval 0 comma infinity, and the function a cross a is equal to a function rho from a cross a to closed interval 0 comma infinity given by rho of x comma y is equal to absolute value of log y by x. And I'm making a statement that this is a metric on A. I'll leave it to you to verify whether this is true or not. But my question here is, for now, take it as a fact and also make a note of it because this is a really interesting example. A is equal to 0 comma infinity open interval, and turns out this works as a metric on this particular set. Question is, why did we exclude 0 in A? What happens if we put 0 in A? Yes, as Mahesh pointed out, if you put 0 in A, what happens is log 0 is one possibility, but even worse than that, our arch enemy comes in. Log of y by 0. That is, any number by 0 can possibly pop up. If 0 is in A, row of say 1 comma 0 will be a trouble, right? It will be log of 1 by log of 0 comma 1 will be equal to absolute value of log of 0 by 1 by 0, which is again a trouble. We mathematicians are always scared of 0 coming in denominator. So along with it, I would like to emphasize on this fact. Make a note of this example. This is a very interesting and very particular example. Note that this metric rho of x comma y works on this particular set 0 comma open interval 0 comma infinity. Add 0 to it, it cannot work. Add any more numbers to it, it cannot work as a metric on that set in more. So this is a very interesting and important example. This works on A, this metric, but this doesn't work on any other set which is bigger than the set. That is, adding even one more element to this set can make this metric not work on the new set. So this is a really interesting example. Make a note of it. Now one trivial challenge, and we'll continue with it. We'll wind up for today. So it said the last line. I'm going to emphasize on the last line of the definition, which said if rho is a metric for M, then the ordered pair M comma rho is called a metric space. Consider R with absolute value metric, which is already proved to be a metric. Which of the following statements are correct? A, double rho comma R is a metric. B, R is a metric space. C, R square comma rho is a metric space. D, R comma rho is a metric space. Leave your thoughts in the comment, and we'll wind up today's session with this. Jocelyn was quick to answer D, and Pranidhi as well. So what is the fact that I'm going to point out here? There's a difference between a set and a tuple. And a set order doesn't matter, but in a tuple, order does matter. Now, I would like to make one note here. Here, by definition, this is, we will say rho R comma rho is a metric space. But in some cases, fact that it's hard to write r comma row always, what we would do is the textbook, most of the textbooks that you learn with, would make a small note saying every time we say R is a metric space, we would assume that R has absolute value metric. So this notation is followed in the textbooks, but before it is followed in the textbook, they'll specifically say, fact that it's very hard to write this each time, we will be following this notation as well, that R is a metric space. Whenever we say R is a metric space, we would mean R is equipped with absolute value metric. So unless R is we are talking about R with absolute value metric, we will say R along with discrete metric has so and so properties. But if we simply say R is a metric space, we are denoting to we are referring to R with absolute value metric. But by definition, option D is the only right answer. Now, I hope we can wind up our session today with this. And yeah, so in next session, we'll be looking at a few more extra challenges, which will be a bit more rigorous, which will be, oh, sorry, let me see. So, no, Bijal, we have defined row for, Bijal just asked if, what happens with option C. So, in option C here, what happens is, r square comma row is not, because row is a function from r cross r to closed interval 0 comma infinity. So r square, it cannot be, row cannot be a metric on r square, the plane. So that's why option C is not correct. It is a metric space only if row is a metric, m comma row is a metric space only if row is a metric on M. For row to be a metric on M, domain should be R cross R. So yeah, I hope it's clear. Now in the next section, we'll be focusing on a few extra challenges. They'll be a bit more rigorous. I'll not show the answer. I'll require you to work it out. So you would have followed this previous two classes, and if you have made a note of it, you'll be able to do it easily. We'll do a couple of CSIR-NET questions in the next session, and we will see why we spend so much time understanding this one particular definition when we are doing those CSIR-NET questions. And then I'll talk about, as I told you, CSIR-NET diary, and then extra reading. There will be a lot more examples and counterexamples listed in the next class. So I hope you found the session useful. Sorry for the network lags, it was unexpected. Anyway, if there are any more questions or doubts, you can leave comments here. Otherwise, we'll wind up for today. Thank you, Bijal. So we'll wind up for today. I'll stop the streaming now. Hopefully we'll continue tomorrow or day after. I'll keep you posted, because I'll post these videos as video lectures in YouTube, and I'll get back to you soon. Thank you everyone, and please don't forget, you can always you can always follow us on our blog, where we keep posting contents. And also you can join the Telegram group for updates on chat, or the updates on the live classes, or follow our Facebook page. So I'll post the links right now. You can follow them for more information. Thank you everyone. We'll meet again tomorrow at the same time.